Monroe and Steve Olmshenk are quantum physicists at the University of Maryland. They are pioneers of teleportation. Their work is all about making connections between events taking place in two separate locations. Events which normally have no connection whatsoever.
We're going to demonstrate a simple experiment using standard coins just to show the randomness of the individual coins and the randomness between the two coins. All right, flip. Heads.
Tails.
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 So as you can see, with two regular coins, we get completely random results between each other.
If Chris and Steve could make the two coins always land the same way, then they would have succeeded in teleporting the information on the coin, heads or tails, from one place to the other. And they had an idea of just how to do this. They would use quantum entanglement, a strange effect that can create a link between microscopic objects. When a bomb explodes and two pieces of shrapnel come flying out, each one moves independently and is unaffected by the other. Now imagine a bomb in a subatomic world. Two particles of shrapnel fly out, but this time, quantum entanglement means the way one moves is entirely dependent on the other. If one piece is spinning clockwise, you can deduce that the other piece is moving counterclockwise. If Steve and Chris's coins were entangled, whenever Steve tosses heads, Chris will toss tails. If Steve tosses tails, Chris will toss heads.
Tails. Heads. So even though the coin flip on one side is completely random, there are correlations between the two coins. And this is the defining feature of entanglements.
Physicists have been struggling to use entanglement to teleport matter from place to place for more than 2 decades. Steve and Chris are the first to succeed. They begin with 2 atoms of an element called ytterbium.
The experiment is we start with 2 trapped atoms. They're across the table from each other.
These atoms are sort of levitated with fields, like a levitated train. They're in a vacuum chamber, so nothing touches them. They're almost complete. They're as close as you can get to perfect isolation.
Steve and Chris write quantum information called qubits into the first atom using microwave radiation. The qubits become the atom's heads or tails.
Then we excite both atoms with this fast pulse of light. And if we do it right, we can make sure that the photon is then entangled with the internal state of the atom.
The photons become the messengers, carrying the atom's information across the lab. Chris and Steve aim the photon from each atom at the same target. When they meet, they become entangled, which in turn entangles the 2 atoms they came from.
They've been nowhere near each other, they've never seen each other, but now these 2 atoms, which are across the table from each other, are now entangled. And they somehow share the information that we first wrote into the first atom.
That's called quantum teleportation because the information, in a sense, never really made the trip. There was never really any physical interaction. It's all because of this magic of entanglement that allows us to do that. And I think Einstein had the best words to describe it. He called entanglement spooky action at a distance.
We start